Okay, so first up we're going to be taking a look at distance formula. It's pretty self-explanatory, right? We'll use distance formula anytime that we need to find the distance between two coordinate points, or we need to find the length of a line segment, right? Distance formula is derived from Pythagoras, and you'll see some similarities between the formulas as well. So into distance formula, we will say that a distance of a line will be equal to the square root of the difference between its y values, all squared, plus the distance, the difference between its x values, all squared. Right, so that is basically it. That's distance formula. So I'll do an example. Right, let's say that we're given a Cartesian plane, y-axis, x-axis, and there's that triangle A, B, C, right? So first we could do something like saying coordinate A is -4 and -2. Coordinate C is, let's say, +6 and negative, I don't know, like 6 as well. Let's just do that, right? And they might then ask you to find the distance, or at least the length of side AC. So we'll go and we'll say the distance of AC. Notice what I do there, D of AC, right? Just to show them that I know what line segment I'm talking about. I will say is equal to the square root. Also with analytical geometry, pop in your formulas, right? Sometimes you'll get marks for them, if not most of the time. So pop them in and then obviously substitute in. Right, so I'm going to say my y2, I'll use C as my second coordinate. So y2 is -6 minus, and notice especially when I sub in negatives, I pop it in brackets, all squared, plus 6 minus -4, all squared. Right. -6 plus 2, because negative is obviously positive, is -4 all squared, plus 6 minus again is plus, is going to be 10 all squared. This is probably not going to work out perfectly, so we know -4 squared is 16, plus 10 squared is 100, so we end up with the root of 116. Can that simple as said? I don't know. Let's check it out. We'll say the square root of 116 to root 29, right? To root 29. And then because it is a distance, I'm just going to pop in units there. They didn't tell me, we're on the Cartesian plane, so obviously my distance, my default distance measurement there is units. Right, so that's how we apply distance formula, and that is distance formula. Again, they can ask it in a number of ways. Something interesting would be maybe they give you B's x value. Like let's say they'll say it's, I don't know, like 3 and then y. And then they could ask you actually to determine y, given that triangle ABC is an isosceles triangle. So for example, if they tell you AC is equal to AB, then we can use distance formula to find coordinate y. How would we do that? We would just plug the same values into my distance formula, obviously then just making it AB, and in this case we know what my distance is. It's 2 root 29. So we'll plug that in, plug in A's 2 coordinates, plug in B's y value for y, so that'll be a variable, and then we'll have its x value, right? So then we can just solve for that y variable. So again, it comes into knowing when to apply the formula and how to manipulate the subject of the formula, things like that. But other than that, just know when they mention distance or length, anything like that, we're just going to apply distance formula. All right.